Hey guys, welcome to part 3 of volume. In this video, we're going to be working on volume word problems. So let's get started. In the first two videos, I went through the different volume formulas and spoke about maintaining pi as a symbol to make life easier when trying to solve for the volume of specific 3D shapes, and the case is much going to remain the same here, but due to the nature of word problems, we might get stuck having to convert things to decimals. So let's see how things work out. In our first example, we're looking at tennis balls in a container, and we need to find the empty space. The container is a cylinder, and the balls are spheres. So let's get those formulas. So the volume of a sphere is 4/3 pi r3. We will have 3 spheres because we'll have 3 balls, and the volume of the cylinder is pi r squared times height. The only information they give us is the diameter, so we only have the diameter of the cylinder. But the diameter of the cylinder is the same as the diameter of the sphere or the ball. And diameter can go in an infinite amount of directions. So that means that the diameter can also go this way. So that means I could take 2.63 and multiply it by 3, and I will get a height of 7.89. So now I have my dimensions for my cylinder and my sphere. The only thing to be aware of is that we are dealing with a diameter, and what we need to do is we need a radius. And the radius is half the diameter. So I'm going to take 263 and divide it by 2. Or you can multiply it by 1/2, which is my preferred method. And I'm going to get a radius of 1.315. Okay, let's deal with a couple of elephants in the room here. So we're dealing with decimals. So unlike my previous videos, right, we're not going to really get around handling pi as 3.14. This is where a really nice calculator comes in handy. I'm going to tell you to do this problem, I am going to punch my entire problem into the calculator. But first, I am going to plug in my information. I punched in my radius, 1.315, both one, and the cylinder requires the height. Now I'm bringing in the other formula parts of the formulas next to it. And as I've mentioned in my other videos, I am using a high quality calculator that employs a math print function such as a TI-36X Pro or Casio 115. Those are the two that I know of, but there are a few others out there, and they are going to make my life a lot easier by just giving me the answer. So the volume of the sphere is 7.24 is fine. I'm going to go just back to decimal points. That's a typical rule unless you have some kind of context. And the volume of the cylinder is 42.86, in this case inches cubed. Now, we do still have one more issue with this problem. And that is that I have 3 balls. So I have to multiply the 7.24 by 3, which is 21.72. So this is 3 balls, or the 3 tennis balls. Okay, now I need to find the empty space. And in order to do that, I need to subtract. So I'm going to subtract the volume of the cylinder from the volume of the 3 balls. And I'm going to punch that into my handy dandy calculator. And I got 21.14. So we have 21.14 inches cubed of empty space. Now, just to add a little bit of context here before we move forward, if we were doing an analysis and we were trying to save materials, in fact, some modern containers of tennis balls have become vacuum sealed to save on material exactly for this reason. These are the types of things that we do this work for. This word problem is not contrived or made up. It is something that somebody would actually do. Alright, let's take a look at the next example. In this case, we have a cylinder that has a volume of 338.3 and a height of 12. What is the radius? So now we are going back as we did to part 3. We're going to do a similar problem here, but unfortunately we're not given nice numbers. So I'm going to start with the volume of a cylinder. This is my personal practice. When I have these types of problems, I make sure to write down the formula first. And the reason why I do that is not to make a mistake there, and also it is simple to stay more organized. One of the things math is supposed to teach us is to organize our tools and to work slowly and problem solve. So I am plugging in the volume and plugging in the height. And now I'm going to start my solving process. Unlike the previous video, I don't have the luxury of having a nice clean number in terms of pi, so I have to actually physically divide pi in. Once again, having a good tool really helps. So I just used my calculator and I used a pi symbol. I did not use 3.14. That, once again, is making life just slightly harder. The calculator gave you a pi symbol for a reason. And that's to make your life easier. That is why it's always worth investing in a decent calculator. Not necessarily an expensive one like a graphing calculator, but a good $25 calculator will definitely take you a long way as long as you're aware of what it does. Now I'm going to divide by 12. I've talked about this a lot. We're dividing by 12 to create a 1 here. I do not like the term cancel out. That insists or insinuates that the object does not exist anymore. And that's not true. We're changing it into something that helps us. And in this case, a 1. Doing so allows us to work through the equation because 1s do not affect multiplication. They don't change the value of a multiplication. That's why we're dividing. Now, I have a square there. I brought this up in the previous video with the sphere, where we had the cube root. In this case, we have the square root. If you were to take this 8.97 and round it up to 3, so then you got the answer 3, I would not argue with you. I would say that's pretty fair. And I say that for multiple reasons. Oftentimes when we take standardized tests, like the SAT, it always says pick the closest answer. And in this case, the closest answer would likely be 3. And the reason for that is because even here, I got the square root to be 2.9. So you have that power and you have that subjectivity, depending on how efficient you want to be. You do have to be careful, and it takes a lot of experience when it comes to rounding like that. You don't want to over-round and then move yourself away from the correct answer. Alright, let's take a look at the next example. Okay, here we have a container, a storage container, which is in the shape of a capsule. And the storage container has a height of 28.2 centimeters and a radius of 5. How many liters of water will this storage container hold? If you watched the previous video, you would have seen me invoke the volume of a sphere and the volume of a cylinder. Formulas to get this done. I am going to now take my information, start plugging them into my formulas very carefully because I've already made a mistake that I had to edit out. So it is very easy to make mistakes here, definitely if you're in a rush. Another factor I should point out is that I noticed over the years students are having increasingly more difficulties plugging into formulas. And part of the reason why I think that is because more and more students are working on computers instead of on paper. So I'm hoping that this illustration of how I am building these equations around these terms by just simply replacing letters with numbers and then writing the rest of the equation is helpful. Now what I'm going to do is I am going to just plug this stuff directly into my calculator. For this first one, I got 523.60, and for the second, I got 2214.82. 14.82. Notice here that I'm really not working these by hand like I did in previous videos. This is just my opinion. While I think being able to work these things by hand is helpful when we're working with simple or primitive problems, when we start dealing with multiplication of decimals in a more advanced case like pi, and then we have 28.2, and now we have to start doing all this stuff by hand, it becomes cumbersome and just not helpful. So we're just going to use the calculator here. I strongly recommend when you're working with whole numbers, right, that you do this stuff by hand and learn the arithmetic. It does take a mature judgment about how you want to approach these problems. Now, I am going to take these two numbers and add them together. When I add these together, I get 2738.42. So 2738, or 2,738 42 hundredths. And what I have to do now is I have to convert that to liters. Well, for every 1 liter we have 1,000 centimeters cubed. The metric system is awesome for stuff like this. So what I have to do is I have to divide, because I am in centimeters cubed and I want to go this way. So it's going to get smaller, right? So the number is going to get smaller. So that's why I'm dividing. So I'm going to divide by 1,000. Essentially, taking my decimal point and moving it 3 points to the left. So this is going to be 2.73842 liters, or as some people would say in human terms, 2.7 liters. Okay, let's take a look at the next example. So Mars is a big giant place, as we think, and it also turns out to be a sphere. So we're going to get the volume of Mars by invoking the volume of a sphere. Now the cool thing about the planets is that they are almost all perfect spheres. Now what I'm going to do is I am going to have to find the radius. Well, the diameter of Mars is approximately 6,794 kilometers. So I'm going to have to take that diameter and I'm going to have to divide that by 2. And that is 3,397 kilometers. So let's understand what the radius is here. We're talking about from the core of Mars out to the atmosphere. That is our diameter. Keep in mind that a diameter in a sphere is, or a radius in a sphere is infinite amount of directions. Now I'm going to take that information and plug it in. So that is my radius. And I am going to build my formula around that. Okay. Once again, there's a practicality to math that I think that we often miss when we are in school. And that is that there is absolutely no positive reason to do this by hand. So I am, as we speak, plugging this into the calculator. And I got the volume is 1.64 times 10 to the 11th power, which is some astronomical number, because we're dealing with astronomical bodies, in terms of scientific notation. That, I guess, would be kilometers cubed. Okay, guys, I hope you found this video on volume word problems helpful.